everyone, let's talk about Theorem 20, the isosceles triangle theorem, and its corollary 20.1 and corollary 20.2. Here with you is Kate Ashley Liao as your tutor. So to further understand what is isosceles triangle theorem, here is an example. So given triangle ABC with segment AB is congruent to segment AC. So prove that angle B is congruent to angle C. So first statement, draw the bisector of angle BAC and let this bisector intersect segment BC at D. So the reason for this statement is every angle has exactly one bisector. Second statement, angle BAD is congruent to angle CAD. So the reason for this statement is the definition of angle bisector, which states that an angle bisector is a segment contained in the ray which bisects the angle of the triangle and whose endpoints are the vertex of this angle and the point or the opposite side. So third statement, segment AD is congruent to segment AD. So the reason that explains this statement is reflexive property of congruence. Fourth statement, segment AB is congruent to segment AC, which is the given. Fifth statement, triangle BAD is congruent to triangle CAD, which is explained by the SAS postulate, which states that if two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the triangles are congruent. So for the last statement, angle B is congruent to angle C, which is explained by corresponding parts of congruent triangles are congruent. So Theorem 20 states that if two sides of a triangle are congruent, then the angles opposite these sides are congruent. So after the Theorem 20, let's talk about its corollaries. So first is the corollary 20.1. So corollary 20.1 states that every equilateral is equiangular. So to further explain this corollary, here is an example. So given equilateral triangle PQR, so prove that angle P is congruent to angle Q and congruent to angle R. First, segment PQ is congruent to PR because all sides of an equilateral triangle are congruent. Second statement, angle Q is congruent to angle R. It is because angles opposite to the two congruent sides of a triangle are congruent. Statement 3. Segment PQ is congruent to segment QR. It is because sides of an equilateral triangle are congruent. Fourth statement, angle R is congruent to angle P. It is because of the isosceles triangle theorem that states that angles opposite to the two congruent sides of a triangle are congruent. So lastly, angle Q is congruent to angle R and angle R is congruent to angle P. Therefore, angle Q is congruent to angle R and is also congruent to angle P, which is also explained by the reason transitive property of equality. So now we have proven that angle P is congruent to angle Q and angle Q is congruent to angle R with this proving. So after that corollary 20.1, let's move on to corollary 20.2. So corollary 20.2 states that each angle of an equilateral triangle has a measure of 60. So to further understand this corollary 20.2, here we have an example. So given triangle GEN is an equilateral triangle. So prove that the measure of angle G is equal to the measure of angle E and is also equal to the measure of angle N, which is 60. So first statement, angle G plus angle E plus angle N equals 180 degrees. It is because the triangle sum theorem that states that the sum of the interior angles of a triangle is equal to 180 degrees. So second statement, measure of angle G plus measure of angle E plus measure of angle N is equal to 180 degrees. So because of this statement, we can substitute the measure of angle G to be equal to 180. So measure of angle G plus measure of angle G plus measure of angle G equals 180. Or we can simply do this. So this is because of the substitution property of equality. So after that, we can do the multiplication property of equality. So after the multiplication property of equality, we can state that measure of angle G equals measure of angle E equals measure of angle N is 60, and that is the corollary 20.2.